Now, let's go to the last part here, how we can graph the logarithmic function. A graphing logarithmic function, it's easy when I don't have h and k. So let me write the formula for you so you can know what is the formula that I mean h and k. So when I have f of x equal a times log base b, okay, x minus h plus k. So if the question that I have, if doesn't has h and it doesn't have k, so of course the question will be f of x equal a log b and x. And when you need to graph something similar to this without h and k, the things will be easy. You just create the table, pick any random value and draw the graph, okay? So for example, let's sketch and analyze the graph of each function and describe the domain, range, intercept, and all of these stuff. Now, the first thing, if I use now the -4 and replace here -4, let's start with -4. So -4 here, any negative value can give me undefined. So here undefined, and here also is undefined, also is undefined. And even if I replace the 0, do you remember when I replace the 0 here for the function, still also undefined, okay? Now when I replace 1 here, so if I put 1, so what do you expect the answer? Don't forget, when I have log 1, what is the answer? Log 1 is always 0, so it's equal 0. Now when I replace 2 here, so log base 3 and 2 is equal 0 point, I think 6, okay? Now let's take one more. So if I take 3, okay, and I want to graph the 3. So now if I replace a 3 here instead of x, so I have the same basis, so the answer is equal 1. Now let's plot the point. The first one is the 1 and 0. Okay, it should be here. Then the second one is 2 and 0.6, so it should be here. Then 3 and 1, so it should be here. Now, if I need, I can graph the function. Okay, sorry. Will be like growing function. Okay, and this one will go close to the y-axis, similar to this. Okay, so this is the exponential function. Now, how about the domain for this one? So the domain from left to right, so the domain is from starting from 0 to positive infinity. The range starts from down to up, so from negative infinity to positive infinity. X-intercept, I have x-intercept at this point here, which is this point is 1 and 0, so the x-intercept is 1. Asymptote, I have the asymptote at the y-axis, so this is the asymptote, so the asymptote is y equals 0, or let's say the y-axis. The limit of the end behavior, so the end behavior when x approach positive infinity, so x approach, this is x approach positive infinity, so this side is x approach positive infinity, so my graph is going up, so because it's going up, it's positive infinity. Now, from the left side, here, this one here, sorry, let me go back. When on the other side, when x approach negative infinity, do I have a function when I have x approach negative infinity? Do I have any graph on this side? I don't have any graph on this side. So I don't have any end behavior when x approach negative infinity. So what should I do? I need to test the end behavior at the asymptote. Where is my asymptote? Okay, which is at 0. So I have to test the asymptote as the 0 limit or of f of x when x approach to 0. Now, if the asymptote is different, for example, let's say the asymptote is 8. Okay, so let's say the asymptote, for example, so let's say the asymptote is 8. So I have to test my function at this point here. So I have to write it limit when f of x, okay, x approach 8. Okay, so the end behavior now for the logarithmic, it depends on the asymptote. Where is my asymptote? I have to test the end behavior at this asymptote. Okay, so because in this question here, the asymptote is at x equals 0, at x approach 0. Now, because this is 0, and this is the right side of the 0, this is the left side of the 0. So do I have a function on the left side of the 0? I don't have any function on the left side of the 0. So I have a function only on the right side of the 0. And if you look to the right side of the 0, so you can see the graph is going down. So because x approach 0 from the right, because we know that 0, when it's minus, this one means from the left. 0 to the power of plus, so this one from the right. So because the function is on the right, so I need to take this one. I don't have any function from the left, so just ignore it. So I have to write now limit f of x when x approaches 0 from the right. Where is the function goes? It's going down. So because it's going down forever, so the function is decreasing, negative infinity. Okay, I hope you understand this. Now the second one here, when is the function is increasing or increasing. So as you can see, the function from start from left to the right, so the function is increasing from 0 to positive infinity. Okay, now let's complete. Let's go to the next one here. Okay, let's do the same thing. So I don't have h and k. Let's pick random points. Let's replace all of the negative value undefined, also with the 0 is undefined. Now let's replace 1. If I replace 1, still I will get 0. If I replace 2 here, I will get negative 1. Okay, sorry. And if I replace 4 here instead of the x, I will get negative 2. Now let's graph these points. So the first one, 1 and 0 here. Then 2, negative 1 here. Then 4, negative 2. Okay, so as you can see, the function will go forever like this. Okay, and it should follow the y-axis. Okay, now let's find the domain. So the domain is still the same thing, from 0 to infinity, because it's related to the h. I don't have h. Range, it's always from negative infinity to positive infinity. X-intercept, it's 1. The asymptote here, the asymptote, okay, check the asymptote. What's the asymptote here? So the asymptote is y-axis, which is x equals 0. And the end behavior when x approach positive infinity, so it's negative infinity, because look to this one here. So if I go to the right, when x approach positive, the function goes down. Okay, because it's going down, so it's negative infinity. Okay, how about the other side? So as you can see, the asymptote as x equals 0. So when limit f of x when x approach 0 from the right, because I don't from the right, so the function is going up forever, so that's why it's positive infinity. The last thing, the function is decreasing because it's decreasing because it starts from what's wrong here, from left to right, so from up to down, so it's decreasing from 0 to positive infinity. Now try to graph this easy question about without h and k, and if you need any help, please let me know. Now let's summarize what we learned about the logarithmic function. How do you know the function is growth or a decay? To just know how we can without graphing. Okay, how can I know if it's growth or a decay without graphing? So just look to the base of the function. If the base is greater than 1, okay, if the base is greater than 1, for example, a whole number, log 3, log 4, 5, 6, 10, whatever, so always the function will go as a growth. And if the base is between 0 and 1, which is considered as a fraction, okay, so it's always a decay. The function will goes down like this. If the base is, for example, okay, let me give you example, log half, log 1 over 4, 1 over 6, or whatever. Okay, and all the properties same as we did in the two example. Now let's take how we can graph the logarithmic function if h and k is given. Okay, so just make it, let's do it easy and simple. Let me remove this function here, so I will graph question A, and question B, question C will be similar to A. Let me now graph A and follow the same step. So first thing, let me remove this one here to the little bit. Let me remove this one up and move this one down. Okay, and take this one, also hide the function. Now let's graph the function. As you can see, first step, when we need to graph any logarithmic function, we have to remember three formula. I need to remember when log of the base of 0 is equal what is undefined. Okay, so because when log x is equal 0 and equal is undefined, this one is my asymptote. Okay, so this one is my asymptote. And the second one, log the base is equal and x is equal 1, so the answer here is equal 0. So this one is my center. Okay, and the third one, log the base same as the x. So for example, I will get any number. Okay, so I will get 1. So this one here will help me to identify the direction of my graph. Okay, the direction. Now let's start solve this. What I must do with these rules? Okay, what I have to do? I have to do this. I have to take the part that inside the bracket here, which is x plus h. Okay, always I have to take this part, and the first time I have to equal with 0. Okay, to find, after I equal 0, to find the asymptote. And also I have to equal with 1. Why equal with 1? To find the center. And also I have to equal this with with b, okay, to find the direction. So the first step, I have to take this one, this term x plus h, and equal with 0, equal with 1, and equal with the base. So the first thing, x plus 4 equal 0. So solve this equation. So it will be minus 4 for both sides. So the first one, x is equal negative 4. So negative 4, so this one is my asymptote. Okay, this is the first step. Step number 2 is to equal with 1. X plus 4 equal 1. So minus 4 for both sides, so we cancel these. So 1 minus 4 is equal x equal minus 3. So this one is my center. So the center will be negative 3. The last one is x minus x plus 4 equal with the base, with b. What's the base here in the function? I don't have a base, so because I don't have the base, so the base always, when it's not given, is equal 10. Okay, because of the common logarithm. So x plus 4 equal b, so let me change b now and write 10. Solve this, minus 4, so we cancel these. So x, okay, let me write it next to it. So x equal 10 minus 4 is equal 6. So this one is the direction. Okay, the direction of the graph. Now let's make the next step. Let's make table. Okay, to make a table, x, y. What should I put in my table? In the table, should take the value of the center and the value of the direction, because you know already this is the asymptote, so you don't have to put it on the table. Okay, so now take x negative 3, put it here in the table. Take x equals 6, put it here in the table. Now what I have to do with these values, just replace these values in the function again, replace them in the x. So if I replace them in the x, so it will be log, let me change the color so you can see. Okay, so the first one is log, okay, log x plus 4, which is minus 3 plus 4 is equal, minus 3 plus 4 is equal 1. So what is log 1 equal? Log 1 is equal 0. Now let's replace 6. Log 6 plus 4 is equal what? Is equal 10. So what's log 10? And here the base is also 10. So because the 10 and 10, so the answer is equal 1. Now let's graph the function. So put the x-axis. We finished. Now let's plot the function. Put the x-axis and y-axis. The first thing, plot the asymptote. The asymptote is given here. The asymptote is negative 4. So negative 4 is here. This one is negative 4. So this is my asymptote. Then plot these 2 points. The first point is negative 3 and 0. So negative 3 is here. Let me change the color. Negative 3 and 0 is here. Then the second point, 6 and 1. So this is 6. And this here is 1. So 6 and 1. So it should be here. So now the graph will goes like this forever. And the asymptote is negative 4 is this one here. So now if I ask you to find the end behavior for this function, okay, so the end behavior when x approach positive infinity is positive infinity. But here, what you have to write here, it's limit f of x. When x approach 0 from the right, no, it's approach, what's the asymptote? The asymptote is what? Negative 4. So x approach negative 4 from the right. So it's negative infinity. So this is how can I graph the logarithmic function. Okay, so which one do you think is represent the function that I graph? So as you can see, I think this one here, it's representing the one that I already graphed because the asymptote of the negative 4. And this one is the second one. This is the third function here, as you can see. Try now to graph the question number B and C, and try to graph 6A, 6B, 6C to practice more on this question. Okay, that's it for today. So I hope you understand the lesson. If you have any question, please text me. Try to solve this one to get the full power. Have a good day. Bye-bye.